Okay, so we're going to do a lab called weight versus mass. Well, I'm going to do a lab and show y'all. So if you're virtual, you need to pause the video right now and you need to write that chart down. Okay? So in the chart, we've got three things. We've got mass in grams, then we're going to convert it to kilograms, and then we're going to find the weight in newtons. Okay? All right. So we have a spring scale. This spring scale can measure grams. There's a G on it, and it can measure newtons. We're just going to get the newtons off of it. We're going to cheat with the grams a little bit in the fact that I already have little weight or masses that are already marked as to how much the mass is. Okay? All right, so we're going to start with, we're just going to find the weight, the mass, and then use that to find the newtons. So I've got this hanger, and I've got okay, so I've got some fishing string that we're going to use. We've got a mass hanger, and I'm going to use that to hang onto the spring scale so we can find our weight. But we're going to start with 50 grams, 100, 150, 200, and then go to 250 in grams. And then we're going to work our way. We're just going to start at 50 and work our way up. So how would you convert that to kilograms?
In the decimal.
How many places?
3.
3. I'm going to move that decimal over 3 places. So in kilograms, this would be 0.05. So we have our grams and we have our kilograms. Bless you. So now we want to see what that's going to be in newtons. So what I'm going to do is I'm going to make sure that this is calibrated. So to make sure it's calibrated, it should be on 0. And it is. Verify for me. Yep. Okay. So if it wasn't calibrated, you would twist this at the top to make sure that it was calibrated. Do what?
Lift the spring.
Yeah, it moves the spring. All right, so I'm going to put the fishing string on there. The hanger itself, because we want to take that mass into consideration, is 5 grams. So in order to get 50 grams, how many more do I need to put on here? I need 45. So I've got a 20, a 20, and a 5 right here. So that's 45 plus the 5 from the hanger. Bless you. All right, and that looks to me like it's about halfway to the 1, so 0.5 newtons is what I would say. You want to verify for me?
Yeah.
Yeah? What you think, Devin?
Yeah.
So we're going to say that is 0.5 newtons.
On the spot. Let me guess. That one's going to be 1.0.
All right, so we want to now add, we want to make 100 grams. So how much more mass do we need to add to this? 50. All right.
1.0.
So I've got a 50. What is it?
I'd say about 1.
1?
1, I'd say.
Yeah.
So it's at 1 Newton now. 1 Newton.
No wrong answers. That one's gonna be 1.5.
Alright, so now we wanna get to 150. So here's another 50. Is it?
Yeah.
1.5 newtons. Verify for me. Alright, let's add 50 more. Make it 200.
Yeah, that's a good 2.
Alright, we're at 2 newtons. Alright, and to get to 250, see, I'm out of 50, so I'm going to take off those two and replace it with a 100, and then add a 50.
Simplify.
We are at 2.5 newtons. So now, we're going to graph this data. I'm going to give you a piece of graph paper. We're going to graph it. What would go on the x-axis? Mass, because that's what I was controlling. I was controlling the mass that I put onto the spring scale, and what we were finding, what was dependent on the mass, was the newtons. Okay, so we're going to graph this. If you're watching the video, I want you to pause the video and draw your graph. All right, so on your graph, you should have gotten something similar to this. What type of graph is that? Linear graph, okay? So let's see if we can establish an equation for this line. All right, so if it's a linear graph, what is the equation for this graph? That's it.
Yeah.
Y equals mx plus b. All right? That's our equation for a straight line, correct?
Yeah.
Okay. Do we know m just by looking at it? No, we don't know m. What is our b? Okay, it's 0. B is y-intercept, right? All right, so we want to figure out our m. We want to get an equation for this line. So one way we can do that is, if we don't know m, we know what b is. Do we know any x and y's? Yeah, that's the order pairs that you just graphed. Okay, so we can just pick one to put in there. So let's just pick an ordered pair. What ordered pair do y'all want to put in there? All right, you want to do 0.2 and 2.0. So our x is 0.2, and our y is going to be 2. And our b, what's our b going to be? 0. All right, so let's plug those in. Let's see if we can find out what would m be. What would our slope be? What did y'all get? put 10, okay? What is 10 really close to? 11? 9.9? Or,
Infinity.
go down one more. 9.8. And what is 9.8?
Gravity.
Gravity. And so what do you think this slope is showing us?
Gravity.
Gravity, acceleration due to gravity. Now, with the spring scale, I should have put it up, with the spring scale, what was the force pulling it down? Gravity. So that's why your slope here.
I don't believe it.
Gravity's what affects weight.
So gravity is what affects weight. So ladies, if you want to lose weight, just go to the moon. Okay, you'll lose weight. Your mass will still be the same, but you will lose weight.
That's an expensive diet.
That is an expensive diet. Okay, so now we can write now that we know slope, we can write the equation for this, and we can use 10, y equals 10x plus b. We know that'll apply anywhere on this line.
The data participation.
All right, so if, let me back up. Where does this line apply?
Does it apply?
Yeah, where does this line apply?
Like where does
On a
gravity
graph?
apply?
Yeah,
Everywhere.
everywhere on
Earth.
Earth.
Sometimes Jupiter.
But what if, speaking of Jupiter, Timmy, I'm glad you brought Jupiter
You're
up.
welcome.
You read my mind.
I do.
Okay, so let me get rid of this right now.
Oh, we're doing one on Jupiter?
If, well, we're just going to estimate if we were to travel to Jupiter. If we could just hop in our rocket ship and just go to Jupiter,
Take 6 months.
what would our line look like?
A lot lower. A lot
And it would
heavier.
weigh a lot more.
What does heavier mean? Does that mean it goes up or down?
What does it mean?
Down, up?
Is Jupiter bigger or smaller than Earth?
It's pretty big.
Okay, it's the biggest planet, so it's a whole lot bigger than Earth. So, what's going to happen to your gravity on Jupiter?
Goes way up.
20
It's
times
bigger
bigger.
and it has more.
The gravity is increased a lot because
So
Jupiter's increased. So, would my line be steeper or not as steep?
Oh, probably. Steeper.
It would be steeper. Okay, it would be steeper. Okay, so that would be Jupiter. It'd probably be a lot steeper than that, honestly.
Yeah.
Okay, so what would happen what would my line look like if we took a field trip to the moon?
There ain't no gravity.
It'd be
It'd be very low.
It would be lower. Good.
It'd be lower than that.
It would be lower. All right. I think that's all for the video. So I'm going to stop that.
You gonna take these up?